Hiya! On today's episode of Preaching to a Seven, we'll have a question on cubic function. If I sound a little bit sick, that's because I am. So, without any further ado, let's begin. Part A. This is a freebie, people, so always make sure to read through the exam. You are asked that for all values of k, the curve passes through this point. All you have to do is to show that f of 2 is equal to 0, and you are done. Obviously, as this is a show that question, you have to make sure that every single step of your working out is clearly shown. Therefore, y equals to f of x passes through to 0. Done. Part B. Find the values of k for which the equation has exactly two distinct roots. Two distinct roots. So, when you are asked to find the condition of a parameter, you can either use calculus or you can just use the factor theorem. I'm more inclined to go with the latter just because it is easier. And if you do the calculus for this, the algebra can be a little wonky. So I would rather not deal with that. So I'm just going to set up long division for this guy. Also, do keep in mind that part A exists for a reason. Okay, let's do long division. Therefore, we know that f of x is equal to x minus 2, x squared plus 2x minus k. Now, it is crucial to read the question. You want to find the values of k for which the equation has two distinct roots. That means that there's more than one value of k. So, what are the possibilities? Case number one. We are guaranteed to have a root over here. So if f of x equals to 0 have two roots in total, case 1 is when x equal to 2 is a root of the quadratic factor. In other words, k is equal to 8. In the second scenario, the quadratic has a repeated root. So delta is equal to 0, or k is equal to -1. So this is pretty straightforward. And you know that you're on the right track because in part C, they specify that k is greater than 0. Okay, part C. Given that k is positive and that the x-axis is a tangent to the curve. Okay, here we go. So we know the curve should look somewhat like this, right? The x-axis is a tangent to the curve. That means that the graph of y equals f of x has a horizontal tangent. We also want to find the values of p so that the line y equals to p intersects the curve at three distinct points. So it would cut at 3 points if the line is between the minimum and the maximum. The question now boils down to, can we find the coordinates of the maximum? We also have the value of k. So this is nothing more than a basic curve sketching question. If k is equal to 8, f of x is equal to this, if memory serves me. Yep. Differentiate, set to 0. If x is negative 2, f of 2 is equal to negative 8 plus 24 plus 16 or 32. Your sketch would look like this. So it will have a maximum at 32, a minimum that lies on the x-axis, and for the line y equals to p, intersect the curve at 3 different points. We know that p has to be between 0 and 32 exclusively. This, I think, is quite representative of a typical IB question. Bark, but no bite. See you next time.